I've tried a number of approaches to serving web pages and web services from the Pico W and Pico 2W. The best approach by far I've found is to use Mongoose. Let me tell you all about it. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT and other fun tech. Remember to subscribe and join the community. Cesanta, the company behind Mongoose, were kind enough to reach out and give me a nudge to show this. It's been on my to-do list for a while. I'm generally impressed with the capabilities and how quickly I could get their demos up and working for this video. If you like this video and it helps you learning or projects, then why not drop me a cash tip using that super thanks button below the video or the payment link in the description. I'm saving these up to get myself to the open source conference in San Francisco, and I'd appreciate your help in getting me there, and of course I'd love to see you all there too. Please hit the like button on the video and subscribe for more. I've done lots of things with web technologies already for the Pico W and Pico 2W on this channel, but they've all been from the point of view of a client, so making my Pico W or Pico 2W into a client. Yeah, I've used lots of different ways of making the Pico W a client, including my own custom code, using bits of the LWIP applications libraries, and using FreeRTOS core HTTP, which is probably my favorite. I explained lots more of how to do that and how to do all of that client side in a course over on Udemy, which goes through how to build up the entire stack and make it secure and all of the complexities in that. What I haven't explained is how to actually do it the other way around and make the Pico W or Pico 2W into a web server. Now there are several approaches to doing that. You could build your own custom HTTP server, and I've certainly done bits of that, or indeed you could use a library like LWIP, which comes with an HTTP server library. The templating approach they use is kind of tricky to use though. I can't get my head around how to explain that to you guys, so it's one that I haven't shared. What I wanted was a nice easy way of getting a web server and web calls up and running so that I could show you how to do that, and the solution to that is Mongoose. This video is sponsored by Cesanta Software Limited and their great product, the Mongoose web server. Mongoose has been around since 2004. It's used in thousands of products and has millions of live units. It supports both the Pico and Pico 2, the RP2040 and RP2350 architectures, plus the Wi-Fi modules used on these devices, as well as some other networking options such as WIZnet modules. Mongoose provides a web server that can serve static files like HTML, CSS and JavaScript, plus calls into your code via callbacks for dynamic functions and data retrieval. It also includes its own TLS library for security and even a wizard for designing your own web apps with minimal front-end development. Mongoose is available either with GPL version 2 with community support or full commercial support via a commercial license. Go check out Mongoose after you watch the rest of the video of my great experience with the product. Right, let's start with Hello World. So any request I send at the web server on my Pico 2W is going to respond with Hello World, basically as a JSON message. Now this example and all of the examples I'm going to talk about in this video are all available for you to download and look at on GitHub. And here's the URL and I'll put it in the description. So Hello World, well this is really very easy to do using Mongoose, and in fact this example is just going to set this up. I need to provide a little bit of stuff, so we're going to need to of course provide credentials. So we've got a little function here which is being very purist and copying my credentials, which are handled by hashdefs coming through from the CMake into the world of Mongoose. We've then got a blink function which is going to just blink the LED while it's running so that I know that everything's okay, always a useful thing to do. And then really most of the Hello World functionality is done here in this function. This is what gets called every time some sort of event happens from the world of Mongoose. And the event we're particularly interested in is when an HTTP message arrives. And every time an HTTP message arrives, we're going to send back a little bit of JSON content, which is going to have the value in it, hello world. And that's it, ready? And then we just clear down these couple of things here to say we've actually done it and everything's done. So what do we actually need to do to get Mongoose to run in the main application? Well, I'm going to do normal sorts of setup and initialization. Then it's really these lines here. So we need to initialize the world of Mongoose. So set up this structure here and then just initialize it. And then we can tell it that we want to listen and the URL we want to listen to there, and that's the callback function to call every time that there is an event. There is a null there. That's actually basically data that we want to send in to that function. So if we wanted to have some class or some object that had data in so that we can get back access to it, that's what that's used for in the callback there. The LED is being controlled by this timer here, and you see we're flashing that every second. And then we've basically then got a control loop, which is just going to call the poll function continuously. And the poll function is what's actually going to trigger the checking of all of the IP stack and the action when an event happens. So that's it, and we never get to this loop down here because we're going to stay there in that poll. So that's all it is, and that will give us a simple hello world example. There are a couple of other things we need to think about in order to use Mongoose, and they're really the configuration to tell it that we're actually on a Pico 2, that we're using the Pico SDK and a few other little bits. And I've set that up a little bit differently to how Mongoose does in their example, because I tend to use this structure where I've got this port folder which has got the port code for configuring libraries and enabling libraries to run on my platform. So in port I've got a folder called Mongoose, and in there I've got the Mongoose config file. I'd much prefer that to putting those config files directly in my source folder. But that's just my strategy. So what's in here? Well, the really important thing in here is, I guess, these two lines, which tell Mongoose that I want it to use its own TCP/IP stack and its own driver for the Pico W, or enable the driver for the Pico W. And I guess the other important line in here is that we're going to use the Pico SDK as well. And those will enable the Mongoose system itself to run everything. So there's no LWIP that we would traditionally use for an IP-enabled Pico W application or Pico 2W application. That's enough to get Mongoose off to go and run it all itself. The other bit in here is credentials, and just link through for the credentials. I showed you where we're actually putting those credentials. These two lines of code just enable that as well. And that's important because we need credentials to be able to connect to our access point, or certainly in my network I do. So that's what that is. But this is all the really key bit. And there's, as you say, not a great deal of configuration to just get this up and running. So in my CMake files, my top level CMake file is actually importing a mongoose.cmake file, which is one I've written that's just configuring that. Let me just show you what's in mongoose.cmake. Well, it's setting up some definitions which you can override of where to find the Mongoose library and where to find the Mongoose port. In my example here, I actually do override them because I'm sharing the same copy of the library. We're going to just add a single source file to it, mongoose.c. We're going to make sure that we've got the include directories for both path and the ports, so the library and the port code. And then these are the libraries that we need to actually make available to it. Now the interesting one here, you see, we need the CW43 driver that comes with the Pico SDK, but in terms of the Pico CYW43 architecture libraries, we're using none, so we're using one that actually doesn't include an LWIP stack or FreeRTOS stack or anything in it. It's just pure, it's the one we normally use just to flash the LED. And that's the one that we can enable to actually make all of this work with Mongoose. And you'll see then in the source level CMake file, I've just got my main as my executable, and I'm just going to link in Mongoose. I've copied, there's a few other things in here, hardware flash, boot ROM, etc. I probably don't need and could actually strip out. They were in their example because their example actually enables you to upload firmware to it and actually flash that firmware. So that's why I just happen to have adapted from that. So my Pico 2W is going to just flash away, and then on the console I'll be able to see some of the data as we connect to the network, etc. But the real show is for us to look at the website and go and actually send a test message. So I'm just going to ask for the asset hello from the web server, and what comes back is a nice JSON message with hello world. Of course, just sending back hello world for every request is a bit useless. So let's actually do something really useful with our web server, and we will control an LED. So what I'm actually going to do is allow us to request which color we want the LED to be illuminated. And I'm going to use Forsaken NGS's Pico LED library to control some WS2812B LEDs. So in hello world, we just responded back with a simple JSON message, regardless of what you were passing through, what URL you're trying to access. If you access the server, you always got the same message. So we're now going to have a look at LED control. And LED control is similar to what we did within the hello world. In fact, very similar. The only real changes here are in the FM function. And now we're actually going to do a little bit of matching in here and say, well, does this URL that you've just sent through match to API/LED? And if it does, then let's see if we can get a parameter from that, which, you know, we're assuming it's an HTTP GET, and on the query you've got a parameter which is the word color, and you've provided some value to that color, to the parameter color of a hex value. And I'm going to take that and then I'm going to pass that off to a little function here called LED control, which is going to actually change the color of my WS2812B LEDs. And I guess we should still continue doing hello world. So we'll also do a check to see if the URL is stroke hello. If it is, then we'll return back hello world. And then finally, we're going to actually also serve some HTML. So one of the nice additional things you can do with this library is you can serve a set of static HTML files. And I've created a static set of HTML files and I've included here, and this bit of code down here actually just makes that whole folder available to you. And basically what I've done there is I've created a very simple application here in under web called index.html, and then which contains just a simple HTML5 color picker. And what I've actually done is then run the pack code, which is a utility that they provide as part of the Mongoose library, to actually pack that into a structure, and that's into this class here, and it basically just, or this C file here, this just basically packs a file system into a single file structure that I can then pass through into Mongoose to make it available as a static set of HTML, CSS, images, JavaScript, whatever I need for my web application in terms of static assets. The one change from last time is I'm now enabling the packed file system functionality within Mongoose. So that's one change into the configuration. apart from that, everything's as it was. So my Pico 2W is now going to control these LEDs. And we're going to basically send it this URL with a color, and there we are, we've changed it to blue. So if we edit now, let's put it to green. Wow, we've made it all go nicely green, and we might as well complete it and put it to red. Let's make it go white too. Now we've also got that static HTML page here, which is our color picker. So I can use my color picker to choose a nice color and then make that go to that color. So here's a bit of a greenish color. And let's do another demo here, and we'll make it go a sort of brownish, yellowish sort of color. There we go. So that's the demo. So the demo so far, I've used Mongoose's own IP stack. And there are a couple of caveats with this. It's certainly really efficient and it's really easy to use, but things like, can I change the DNS name that my device is advertising? No. Your DNS name is hard-coded to be MIP. Can I move to access point mode rather than SDA mode? Not that I can see easily. So you've got a few caveats to worry about. You can of course get around those because we can actually switch Mongoose to use the LWIP stack. Now that does require that we actually enable FreeRTOS kernel and use FreeRTOS kernel, because at that point it's not only going to use LWIP, but it's going to use LWIP sockets, and LWIP sockets require FreeRTOS kernel. So let's do the same demo, but we will this time use FreeRTOS kernel and LWIP, and I'll show you how I set that up. So as I've just said, there are some limitations, though not terribly serious ones, in using the Mongoose IP stack. Now, you're going to drop efficiency a little bit if you drop back to LWIP and FreeRTOS kernel and running the stack, but you gain some advantages as well. So in this example, LED control LWIP, I'm actually using the LWIP stack and the sockets library within LWIP, therefore I've got FreeRTOS in there, in order to actually run the same functionality as we were doing with LED control. So the changes now really are that in main, in how I start up, is that I'm actually going to basically initiate a task called Mongoose, and that task has got 8K of stack space, and that task is basically going to be the one that does the initialization of Mongoose, and then it's also then going to use CW43 and ARC to start up SDA mode and connect to Wi-Fi, as we would traditionally do in a Pico W application. And then we're going to do the listen and we're going to do the poll. So most things are the same. It's just running inside a task here. And the rest of the code is the same. The libraries situation is a little bit different, I must admit. So first of all, let's just have a look at port, because port's suddenly gone a lot more in here. Not only have we got Mongoose, which is important, and we're telling Mongoose that we're actually enabling the LWIP stack and want it to use that, and that we're not going to use its own TCP stack or the Pico W driver, because we don't need to, because LWIP is going to give us that. And then I've also got configuration in there for LWIP and for FreeRTOS. And I've got other videos talking about that. So then if we have a look at what when we're linking, we're actually now going to link the Pico's CYW43 ARC LWIP sys FreeRTOS. So we want LWIP and FreeRTOS support. We want FreeRTOS kernel heap 4. We want my configuration of FreeRTOS, as well as the other things, and of course Mongoose in there, because this is now going to, yeah, absolutely be a proper FreeRTOS application. But it actually just runs the same, it's just running that task. So this does now mean that I can be slightly clever, and that this line here allows me to configure what the host name that the Pico 2W is going to be known as on my network. So when it does the DHCP request to the server, it's actually going to say, and I want to be called Pico 2W Web. And that can be useful because I can then access it as that name, certainly in my network anyway, because my routers provide that DNS lookup capability. If we look at standard I/O, the output of this as it starts up looks a little bit different from a demo point of view, but otherwise the actual functionality of the device and how it's responding to HTML requests is exactly the same as we've seen on all of the previous demo. And if we're gonna have FreeRTOS there and therefore multitasking, we might as well demonstrate it. So let's do a little bit of animation. So final example, as we're playing around with FreeRTOS and we've got that running again, we probably should do something a little bit clever and just demonstrate that actually I can animate some stuff. In this example, I've created an LED agent, which is going to be basically responsible for putting the LEDs into a strobing pattern where they just going up and down in a strobing order, then I can change the color of that LED as it's actually moving up and down. And I'm just running that, so we've now basically got two tasks. Now this example's cheating a little bit because really I should be being careful here and not directly calling a function and changing data that's being used by a different task, but I am actually doing that because I know I can get away with it, because I know it's a single 32-bit value and it's pretty easy. I'm unlikely to get a clash, and even if I did get a clash, it's not going to kill my code. I'm being lazy in how I've implemented this. Really, I should be putting a nice messaging queue in place and sending stuff across properly via message and looking out for that message. I'm not doing that. Do it properly if you're doing this stuff. So we now strobe the LED, and then I can change the color using the web interface, just as I did in the previous demos. So, you know, I won't bother showing you the simple web browser. In this video, I've only really touched the surface of Mongoose capability. There's also an entire framework for the development of web applications for your embedded platform. This is kind of neat, as not everyone finds it easy to be a full stack developer and therefore do web development as well as embedded development. Certainly web development is not something I really want to do. I also see libraries for SNTP and MQTT in here too, so there's a lot of other potential we could get out of Mongoose. If you'd like to see more Mongoose videos, then please do let me know in the description below. I'll see what I can do. If you like this video and it helps your learning or projects, why not drop me a cash tip using that super thanks button below the video or the payment link in the description. Remember, I'm saving these up to get myself to the open source conference in San Francisco, and I'd appreciate help in getting me there, and of course I hope to see you there too. Thank you very much for watching. If you enjoyed the video, then please do hit that like button, and please subscribe to my channel so you don't miss the next video. Goodbye for now.